This conference will now be recorded.
Okay, so now let's get started with Kubernetes. So, so here Kubernetes will bring health, wealth, and happiness. Okay, so health for you, wealth for organizations, and happiness for both of us. But the question is how? So for that, you need to understand what is Kubernetes, and then you need to understand Kubernetes architecture. You need to install Kubernetes, work with the pod and deployment and services, and many more. Okay, so this is the something which you have to do that. So guys, one thing I will request you, when you are learning Kubernetes, okay, then you should assume your role should be in the production server. That means you are managing a production server or managing a large set of applications in data center or something like that. So if you put in that context, Kubernetes will be very easy to understand. Okay. So now, what is Kubernetes? In order to understand the Kubernetes, you need to understand four questions. One more thing I must tell you here: the speed for these topics which I'm covering right now, I'll be little fast. The reason is because I don't want to do the fundamental training actually. So and I see that this is a part of the agenda. So I want to cover but little fast. So that way we should focus on the advanced topics also. Okay. So when you feel I am fast and you are not able to understand, so please feel free to interrupt me and ask for the clarification. So, will that be okay for everyone? All of you?
Yes.
Okay. So, please help me with that. So, yeah. So, what is Kubernetes? So, if you want to answer that, what is a Kubernetes, then you have to understand where did it come from, what does it do, what does the name mean, and so on, and why do we have it in first place. So, guys, Kubernetes is born in Google. Yes, donated to CNCF by Google in 2014 and is become open source. Now, this product is written in sorry. So go Golang and the code you can find at the GitHub. There's a website kubernetes.io Slack channels and meetups. So this is a little bit information about Kubernetes. Now where did it come from? So if you look at this Kubernetes, the DNA is matching with the Borg and Omega. Now the question is what is Borg and Omega? So I'll put it in a very simple and straightforward manner. Borg and Omega is a platform on which Google services runs. Now whatever the services you are using, Google search, Gmail, this, that and all, is running on the Borg and Omega. That means Borg is managing all the runtime environment and so on. So just imagine the kind of data center Borg is managing. Imagine millions of servers, hundreds of applications, billions of traffic every minutes. Just imagine. So such a sophisticated software you have, which is a proprietary. So now I'm not saying that Kubernetes is an extension of Borg and Omega, basically, but because Kubernetes is also coming from the Google, and Kubernetes is also something doing something similar what Borg and Omega can do. So then we can say DNA is matching. So Kubernetes is open source, whereas Borg and Omega is a proprietary for the Google. Okay, so in short, we can call it chaos. This Kubernetes keyword has been taken from the Greek word, which is in real, they call it helpsman. So, what is the helpsman in Greek? So, helpsman is the person who steers the ship. So, the size of the ship, it can be small fishing boat, or maybe largest petroleum vessels, or maybe aircraft carrier. But if you look at this, no matter the irrespective of the size of the ship, that only one person can control the entire ship. Okay, so same way, what I am trying to say here, Kubernetes, if the data center you are running, the application runtime environment you are running in the container. So Kubernetes, if you have worker, one node worker clusters for the Kubernetes or thousands or 10,000, Kubernetes can manage it. So Kubernetes is your helpsman, not you. Okay, Kubernetes is your helpsman for your data center. Okay, so that is something like that. So yes, it's born in Google, donated to CNCF in 2014, open source. First release has happened in July 2015, and blah blah blah. Are you comfortable with it? What is Kubernetes? Any questions? Any questions, guys? Hello.
No, Rajesh.
Okay. So now the question is, I'm having in my mind, why do we need it? So simple reason, guys. Containers bring scalability challenges. Okay. Now I'm assuming because you are going through the Kubernetes advanced topic, so I'm assuming you have a fundamental knowledge of Kubernetes, though you must be having. Some of you already said that, but also you need to have a Docker knowledge actually. If you don't have a Docker knowledge, container knowledge, then it's very difficult to visualize the use cases of Kubernetes. Okay, so container which is powered by Docker, okay, which has a lots of scalability challenge. Scalability means, see, if I want to run few containers in my laptop, that's okay. But if I want to run containers in a data center where in a thousands of machines, then the question is, how can you manage it? That is a problem. Scalability challenge. That means everyone loves container. Why? You know that. But it's not scalable at the data center. We need some better solution than only Docker. Okay. And we are starting to view the data center as a computer. That means, let's say, I'll put it in this way. Let's say you add one laptop. You have one laptop and you add multiple CPU, RAM, and multiple storage. So still, when you install the operating system and then when you install Docker on top of it, then the Docker assume it's a multiple compute unit or one compute unit. It's of course one compute unit. So same way, data center with thousands of node worker, thousands of CPU, RAM, and storage, but we need a software who should see entire cluster as a one compute unit. How can you make it? That is a problem. So with the Docker cannot make it like that. So what to do? So look at this here. This is the image of of Docker. Are you comfortable with it? This image? Tell me yes or no. This is the Docker image.
Yes.
Great. So
Yes.
guys, we all know that Docker manages the container. Wonderful. Now, this is the architecture of Docker. I am sure you might have gone through before Kubernetes training. Are we okay?
Yes.
Okay. So guys, very simple questions. Okay. This is the very simple questions. See here. There is a one host and there are the three containers. So containers is being managed by Docker. But if I want to run the application at the larger scale for the large scale of people, then what we need to do? This see one host you can run maximum of three container as per the image. So if you want to run more than three container for the traffic, more traffic, what do you need to do? Then simply you will say, Rajesh, add a new host. What's the big deal in it? You are running right now three container in a host and you require 15 container, add five nodes. Simple calculation. What's the big deal in it? There is a big deal in it. When you add a more host, how can you manage those hosts? Because Docker cannot do that. Are you going to manage individually each server manually? That means for managing the millions of server, mind it, there's for the managing millions of servers, am I going to hire thousands of engineers? That's the question. Who would manage multiple Docker hosts? See, so that's what I'm talking about. Containers bring scalability challenge. That means when you scale the containers to the production level, to the large scale, then you have a challenge. Who would manage that multiple Docker host now? That's a question. Now, if you know Docker very well, then you know that you can run a container, let's say Apache container in your Docker host. As many Apache container, you can run it. You know that very well. But remember that when you expose the container outside of that VM, then you have to use the port forwarding -p option. I am sure you might have used it. So now remember that if you have consumed the host port one for one Apache, you cannot expose the another Apache on the same port of the host. Agree with me? All of you? Agree with me?
Yes.
So the question is, how can we, because if you cannot, see, if you're running two Apache in one host, so one Apache you expose with 80 port on the node port. Second Apache, how can you expose? You can't expose. And if you can't expose, both the Apache, which is running the same VM, cannot be load balanced, because you know that load balance required the different IP address, same port number. Correct? So there is a networking challenges with the containers. How do we solve it? How to load balance multiple containers running with same port in one host? So Docker has no solution for time being. So how do we deal with it? How do we deal with it? So that we need a better solutions for it, networking, which can solve the networking challenges. Okay, now there is a one more problem. See here, in a data center you are running 5 hosts, 15 containers. Now all of your traffic required 15 containers. Okay, so if let's say if you run lesser number of computer containers, then what will happen? Your response time for your end user will grow. Now, when the response time of the end user will grow, of course, you know that what you will do. Let's say Ola is slowing down. Ola, if you are using Ola app, is not responding. So what you will do? Jump to Uber. You know that very well. So now what will happen in the production server when you run multiple container in the multiple host? Some host may go down. Okay, if some host may get down because of hardware issue, network issue, storage issue, application issues, any issues, I don't care, but it's down. Now you need a 15 containers to serve the traffic. So how do we fix this? Am I going to call you around 3 o'clock night? You are going to call the some IT people, L1, then IT, then dev, then manager. All these people will call, and by 6 o'clock, everyone is in 6 o'clock morning. Everyone is in meeting and fixing the problem. And by the end of the day, you fix the problem and solve the issues. Are you going to do that? No. We need a tool. We need a solutions which has a capability to auto healing. That means if two node is down, 6 container is down, we need 15 containers. That means we should immediately, the moment the 6 container is down, two node is down, we should have a two nodes addition and 6 container addition immediately within seconds. How do we do that? How do we auto heal? That is a challenge. So these are the kind of challenge. We need a better storage. For that, you need a data center storage capability, security you need, load balancing feature you need, auto healing functionality you need. All this is our scalability challenge. When you scale to the larger scale, you have so many challenges in the container world. If you want to bring the containers to the ops, to the data center, to the production, then you have so many challenges. How do we deal with it? Are you understanding, all of you? All of you? Hello?
Yes, yes.
Yes,
Yeah,
Rajesh.
Rajesh.
So guys, who can solve this problem? Kubernetes can solve this problem. So Kubernetes can solve the problem for the container challenges with the container scalability. Now you have to set your mindset also, guys. When you are in Kubernetes training, you have to think as a business owner of cattle. Okay, how? So let me put it up in this way. Now let's say if you have a pet, okay, one pet, you will basically take care of it, love them. Something goes wrong, take to the doctor, this, that, and all this thing you will do that. Okay, because it's a special one, right? Same way you did with the containers also. So containers, you work with the container, troubleshoot the container, in, out, all this thing you did it. But now when you are in a Kubernetes training, you have to think as if you are the business owner of cattle, and your primary objective to deliver 100 liters of milk to the your client. Let's say sometime if some of the cattle are not working well, so would you say your client saying that, hey, today my cattle is not working well, you have to adjust with 80 liters of milk only? Would you say that? No, your customer will change the vendor itself, correct? You can't say that. So as a business owner mindset, what you will do, immediately you will replace the cattle, bring the new cattle who can perform and reach to the 300 liters of milk. That is your objective. So when you are in a Kubernetes session, your objective is to run 1,000 containers within a Kubernetes. That's your objective. If some nodes are not working, no problem. I will not troubleshoot. I will replace with the new container, new pod. Okay, so kind of mindset you have to build in Kubernetes. So Kubernetes will immediately replace and do the things. So yeah, when you are learning Kubernetes, main objective to run thousands of containers in a cluster. If some containers is not working, replace with the new container to make sure that the actual number of containers must always match with the desired number of containers, and that is your objective. Because remember, you are in operations, you are in a production team. That is your job, first job. Okay, so what is a Kubernetes? So Kubernetes is a container orchestrator. Orchestrator means if you want to run container at the large scale, then you need Kubernetes to manage that large scale infrastructure. Kubernetes is a workload placement also. What is that workload? Workload, whenever you see, workload means container. Workload means pod. What is a pod? I'll discuss in some time. Placement means, workload placement means Kubernetes, because you are running the production server in the thousands of machines. So here Kubernetes will decide which node, which container I should run. That's a default settings. Okay, you can influence that one also, but it's okay. Kubernetes has a workload placement capabilities, infrastructure abstraction, lots of complexity in Kubernetes, but it's hidden beneath the cluster. You don't have to worry about it, like networking, security, storage, compute, all this thing is hidden beneath the cluster concept. And desire state, so Kubernetes manages your desire state. So Kubernetes, you said, hey Kubernetes, I need 30 pods or 30 containers at any given point of the time. So Kubernetes will make sure that it always should be 30, not less, not more. Make sense? So this is the some of the properties and characteristics of Kubernetes. So Kubernetes has a self-healing capability. Kubernetes has automated rollout and rollback capabilities. Kubernetes has an auto-scaling capability. Kubernetes has a load balancing capability. Okay, Kubernetes, using that you can do the deployment in at the extreme speed actually. That means, let's say if you want to deploy 10 thousands of containers within a second, you can do that. You want to upgrade the containers within a second, it can be done. You want to roll back the latest to the previous one, within a second it can do. Or all the complexity is hidden in the cluster itself. Okay, so Kubernetes also can help you for or storage orchestration. Okay, by the way, let me tell you, Kubernetes has a multiple benefit. For example, Kubernetes is a container orchestrator. Kubernetes is a microservices orchestrator. Kubernetes is a storage orchestrator as well. Okay, so many things is happening. Kubernetes can manage your secrets as well. Kubernetes can do self-healing, automated rollout, rollback, and discovery services also is there. Service discovery and load balancing. So many features which you have in Kubernetes. Okay. So using the Kubernetes, you can enhance the productivity of your software development. Deployment are faster and simple, lower overhead, improvement in security, increase in portability and immutability. Okay, so these are the things about the Kubernetes. So on top of that, guys, Kubernetes is moving fast. So if you want to be in line with all the technology which you are learning with Kubernetes, you have to keep practicing all the time. So guys, this is a Kubernetes. Any questions so far? Any questions so far?
No, Rajesh.
Okay, so with that, we'll get into the now understanding of the Kubernetes architecture. That means how Kubernetes works. So you saw that so many functionality you have in Kubernetes, but how exactly it works, we need to find out an answer for it. Okay, so let's get started. Architecture. So guys, I'll just skip some of the stuff. Huh. So when you look at the Kubernetes architecture, okay, so first thing we say, hey, we have to set up a Kubernetes cluster. So what is a Kubernetes cluster? So Kubernetes cluster, you have multiple virtual machines. You can call it a node. Okay, multiple nodes. You may have a one node, 10 nodes, 20 nodes, 1000 nodes, and number of nodes. Okay, but these nodes play a two different role actually. So one role is worker node, another one is master node. So master node managing the cluster. So master node has certain software installed which manage the software, which manage the cluster. Worker node, a node where you run the containers. Actually, you run the pod, but right now containers. Okay, so this is a cluster. This is the architecture. So you have a cluster. Clusters have a master node, worker node. Okay, now master node is instructed by some packages, deployment packages, which you have to deploy it yourself. Okay, so are you at a high level? Are you comfortable with it architecture, all of you?
Yes,
Yes.
Rajesh.
Not,
Yeah, so master node do the work in his who's in charge of the cluster, doing and managing all the cluster. Worker node is doing the work. Work means running the container. Okay, and if you look at this here, in this image, deployment package is sent to master, and master have a certain component which deployed to the worker node. Work is being deployed to the worker node. Now in worker node, there is a one icon which you see carefully. There is a pod, and inside the pod, do you know what is that image? Anyone have idea what is the image of that inside a pod? What is the image? So that's a container image. So if you look at this here, in Kubernetes, we always deploy the container in a pod. What is a pod? We'll discuss slowly, but we'll get into that. So this is the pod. So worker have a pod. Inside the pod, you have a container. Okay, so now let's focus on the master node only first. So we call it the control plane also. Okay, control plane. So now master node always has to be Linux. Worker node also always has to be Linux. But there is one exception. The worker node can be Windows also. So Microsoft has started supporting the container from the 2019 onwards. So yes, 2019 plus the operating system in Windows, if you use it, that has a support actually. So yes, master node always has to be Linux, but worker node can be Linux or Windows 2019 plus. Okay. Now, if you see that master node have four components. So if someone will ask you, hey, in the cluster you have a role is master node and worker node. So how come a node can become a master and how come a node become a worker? So for that, you have to tell master have a four component, four software running. Which software? I'll discuss in some time. Now, master is very important. Master is very important for managing the health of the cluster. So if one master is you are having, this is at a greater risk because master is down, entire clusters will be down. So in that case, what you should do, you should have a multiple masters. We call it a multi-master HA. You should set it up. Now, if you look at this image, here you have a master node. Inside that, four softwares are there. That's a primary one. More softwares may there. And then master node manage the worker node. Okay, worker node. And if you look at the left side, worker node, you have a pod. And inside the pod, you have two containers. And right side, if you look at this, you have a multiple pod. And each pod, you have a each container, one container. So that means what I'm trying to say here is master node manages the worker node. Worker node can be Linux and Windows, and each worker node you may have one pod or multiple pod. Yes, worker node you may have a one pod or multiple pod, and in each pod you may have one container or multiple container. Mind it. What is a pod? We'll discuss, but containers I'm assuming you know that already. Okay. So if you want to run container in Kubernetes, you have to run inside the pod. Are you comfortable with it? All of you? Yeah. Now the question is, which are the four software required so a node can act like a master? So these are the four software. So first software, which we call it API server. Okay. So what is API server? I'll put it in this way. I assume you know about the API. Okay. So when I say API server, that must be in this component in the software, you must be having hundreds of APIs. Okay, yes, that's true. So let me put it in a very simple way. Any functionality which you can find in the Kubernetes, maybe 100, 500, whatever the functionality, is been growing a lot. day by days. So whatever the functionality you have in the Kubernetes, actually those API is managed by API server. That means if you want any functionality, any API in Kubernetes, you have to send a request to API server. Without that, nothing works. So let me put it in a more simpler way. Any communications you send from outside to the cluster, you have to send to API server, which is running in the master node. Okay, internally also any internal components also, if they want to send any things, they will have to send to API server. That means API server is a front end to the control plane master node. And how can you access? It's accessible over the HTTP REST API, and you always request API server in a form of JSON. Okay, so this is the first component. Second component, we call it cluster store. Basically, cluster store is like storing the data, persistent data. See, any applications you run, you need some database sort of it. Why? Because you can store the persistent data for the permanent to reuse it. So here we have cluster store. Now you'll say, okay, this cluster store software, how is been empowered? Empowered means, is it being used MySQL, MS SQL, Oracle, RDBMS, MongoDB? What exactly is being powered? So basically none of this. It's powered by etcd. So yes, the database name is etcd. Now what is etcd? So etcd itself is a graduated project from the CNCF. So CNCF have a more lots of product actually. They have a Kubernetes, they have Prometheus, they have etcd, and hundreds of it. Okay, so etcd is one of the kind of database which store the data in a key and value format, and it can be set up. It can be distributed also, consistent, watchable, and it is a source of truth. Source of truth means if anything you have in the etcd cluster store, that means that is exist in the cluster. If it's not here, that means it's not exist in the cluster, and you need to have a backup plan for it. So that is the second component of Kubernetes master. Third component which you have is a controller manager. See here in the image you have a controller, but in the description you have a controller manager. So mind it, controller manager manages multiple controller. Now we'll think, what is a controller? So controller, you can assume, is like a check. It's like a script which keeps running in the loop. For example, controller manager will have a hundreds of check, hundreds of script. I'm just help you to visualize in an easy way. So controller manager will manage all the controller. Controller means check. So each check will check something like a node is up or not, endpoint is up or not, namespace check, this check, that check. So all this Kubernetes cluster, whatever the components they have it, whatever it can be created by cluster or you, they will keep monitoring. Each controller will keep monitoring and keep informing to the API server. So API server, you, because of controller manager only, API server will come to know, okay, this is the status of my cluster. Okay, so it's always, you can say it's like a monitoring tool for the cluster, and which keep updating the API server about the states, node is up and running or not. Okay, some port status, endpoint status, service status, and all stuff like that. It's keep updating. Okay, so controller always runs in the loop. Now, fourth component which you have in the Kubernetes, which is scheduler. So, what is a scheduler? Mind it, just understand the scheduling capability. It's as the name suggests itself. Scheduler means it schedule the work. It's not doing the work. Schedule the work. So, what happens? Whatever the request you send from outside saying that, hey, I need a 10 container. Okay, 10 pod. So you send to API server. API server stored that in the cluster stored. Controller manager say, okay, there is no such pod is available. So API server will ask scheduler, hey scheduler, go and schedule the work to the multiple node of the cluster. So it schedule the work. It watches the API server for new pods and assign the work to the nodes. And you can influence this scheduler based on affinity and anti-affinity, constant resource, and stuff like that. Okay, so these are the four components which must be needed to function one node as a master node. Are you understanding, all of you?
Yes, sir.
Yes.
Okay, so now this is the master. So master node. So can you please tell me? Okay, she is my favorite actress. So can you please tell me? This is the her face. Any human body has a something similar face. Which component of her face is acting like an API server? Quickly,
Eyes.
think API server receive all request.
Years.
Years, correct. Yes. So 2 years is being given. So if is one is not functioning, second will work. So HA, you should always think about master making as a HA. Okay, fine. So that is the first thing. Second thing, which part of the component will act like a persistent storage cluster stored like a etcd or something?
Brain.
Brain. Wonderful. Now, which part of this her face will act like a controller manager? Controller manager have multiple controller and monitor everything and update to the API server and stuff like that. Which?
Eyes.
Eyes, right? You have two eyes. So controller manager also have a multiple controller actually to check everything. And which one will act like a scheduler? Schedule the work, not doing the work, schedule the work. She's a queen, right? So she can schedule the work, she can instruct the work. So how?
Mouth.
Mount. Yes. So now you see that how beautifully it's designed actually. So this master node can manage entire cluster because of this. So receive, store, monitor, and schedule if mismatch. This is how it works. So guys, this is the master control plane component API server, which is central, simple, restful, update the etcd, cluster store, which persists state, key and value format, powered by etcd, watchable. Scheduler watches the API server, we help you to schedule the pod to the node, have a resource constraint and respect the constraint. Controller manager always runs in the loop, has a controller managing you to lifecycle function and desired state of the cluster and watches and update the API server replica sets and so on. So now this is a little bit broader picture. So see the master node and the right side you have a node where the pod is running, and then in your laptop bottom side you see there's a laptop, and laptop you have to install one utility which is called kubectl. Okay. So in your laptop you install a kubectl, you write a JSON file, you send it to API server. By the way, you can write a YAML file also. Kubectl will convert the YAML to JSON and send to API server. Why? Because API server always consume the JSON file only. So this is the one architecture. That means if you want to talk to API server, that means Kubernetes, you have to install the Kubernetes kubectl and configure the kubectl. Okay, understood? All of you?
Yes, yes.
Yeah. Yeah. So now let's focus on the worker node. So worker node means we can also call it minions also, or typically in the official documents we call it worker node. So now the question is what is worker nodes and what are the components you have installed in the worker node, so it will become act like a worker. Okay, so have you seen the movie called Minions, all of you?
Yes.
Yeah, so Minions movies, the role of Minions is also somewhere matching with the Kubernetes worker. Okay, I'll tell you how. So the purpose of minions, life purpose of minions is nothing without a master. That means worker, there is no life without a master. So that's one thing. Now minions decide who's your master. Same way worker will decide who's your master, and once the established connection is established, that means relationship is established, then now master will instruct the minions to do whatever you want and then do the work and send the report back to the master. And this relationship will continue till you have in a master and worker relationship. So it's like this. So now the question is, how can you create a worker node? What are the software you need to install? So basically, you need to install kubelet. and Docker and kubeproxy. So what is a kubelet? So you can say kubelet is your agent. It has to be run in each worker. If it's not working, if not running, then this worker cannot act like worker. Simple. Okay, it's an agent. Now agent only register with the master. Okay, after registration, successful registration, it keep watching the API server for the request, and then kubelet only instantiate a pod. See, I have not discussed about the pod, what is a pod, but so far we know that if you want to deploy the container in the worker node, you have to deploy in the pod. So who instantiate a pod? No, kubelet, mind it. Okay, and once the pods is being created, instantiated, whatever it is, report back to the master, and kubelet is accessible on the port number 10255. That means if you want to configure the worker node, what you need to do, install the kubelet and register the kubelet, configure the kubelet with the master. Simple. How that process I will show you anyways. So just forget about that how part, but understand that the role of kubelet. Docker, I think you know that. This is the container engine. Here it can be Docker and Rocket. By the way, the latest version of Kubernetes, which is 2.1.23 and 4 and plus, Docker has been removed as a default container engine. So anyone have idea which is the replacement? What is the replacement with? Anyone have idea?
No, I don't.
So container D. Container D. Okay. So you should start looking into the container D also, and maybe next year or so you will probably migrate and something. Okay, so container D is the support for the Kubernetes latest version. Now there's a third component you need to configure, okay, and that's called kubeproxy. Okay, so what is a kubeproxy? So kubeproxy basically helping you to set up a networking challenges. Okay, so whatever the networking challenges you have, which is solved by kubeproxy. Now kubeproxy I will discuss in little detailed way. Okay, why? Because that is a part of understanding the stuff. So what is a kubeproxy? So kubeproxy basically helps you to assign and allocate IP address not to the container but to the pod. Okay, so kubeproxy only get you the pod IP address. Now, because of kubeproxy only, all containers in a pod share the single IP. That means in a pod you may have a multiple container. So you, let's say 2 or 3 containers. So each container how they will see the IP address. So each container's IP address is nothing but a pod IP address. Okay, and because of kubeproxy only, load balancing across the all the pod is working. That we call it a service. Service is a load balancing feature in Kubernetes. So because of all this thing is happening is because of proxy. Now we'll say what is a proxy? So proxy is basically merging the two network. Okay, so in Kubernetes cluster there is one network you set up. We call it a pod network. Okay, pod network or clustered network. Okay, and there is a one node. There is a one more network which you have is a node network. Now the communication between the node network and pod network, and also talking to the API server for the subnet CIDR and all stuff like that, then proxy is very useful. Okay, so proxy has to be running in the each worker, each node, and all this stuff. So this is how LS is a one network, Bob is another network, and that is how using the proxy they connect and share the data. Okay, so what Kubernetes has done it, Kubernetes has published the networking requirement for the vendors. Those who are writing the software for networking, they have published networking requirement. So what networking requirement? So Kubernetes says if you apply any networking driver, we call it in Kubernetes policies, then these three criteria should be fulfilled. Which one? So all pod can communicate with each other on all nodes, because in a cluster you have hundreds of nodes and hundreds of pod will be running for the containers. So all pods should communicate with each other irrespective of the node, any node. and all the nodes can also communicate with all pods and without a NAT. So that should be done. So anyone who is developing the software for networking who fulfills this requirement, those will be considered as part of the Kubernetes networking solution. So there's so many software has been written. So I will show you some of the software first. So networking policies of Kubernetes. Okay, so there's so many driver has been written, okay, which fulfill this criteria. So now I will say which one. So let me see that. I think this is a wrong page. See, so these are the things. So only small, some of these are there. I want the mm, I want the list of it. So there was one page. There was one page. Okay, no problem. So this is sufficient. So these are the one. Okay. So these are the see here. There are the number of networking providers that support networking policy, including this one. So this is the small list actually. There are few more actually. Maybe five is missing. I mean, altogether maybe 10 more. So these are the policies. That means these are the different software actually. You can say policy means software. So this software fulfill this criteria. What criteria? So that means if you use this driver, this software in the Kubernetes for the networking solutions, then what will happen? This will be fulfilled. That means all pods can communicate with all the nodes each other and all these things what I was said. So as part of these discussions, I am going to use Calico. Okay, Calico is one of the very stable networking solutions and all this stuff. So by the way, there is a each cloud they have developed their own networking policies also. So Calico is one thing. If you want to know the Calico official page, this is the one. Here it is. So it's a product actually. This is one of the driver. Implementing is very simple. Just one line of code, one YAML, you apply and then it will be implemented. That's not a problem. Okay, so this is the driver, number of policies you have to understand. Now there's a VivNet, there is a Calico, all these things. So if you are really implementing and architecting the production server, then what you need to do, you need to study the VivNet, Calico, and other policies also, and pros and cons, and then see which is suitable for you. If you are going for the managed services like EKS, AKS, and all, then don't worry about that because that time if you are going for managed services, those policies been controlled by your cloud provider only. That means AWS will have their own policy written for managed services. So that way you don't have to worry about it. But if you are setting up your own customized cluster environment, in that case, you have to take up a call which policy is good and fulfilling your requirement. Make sense, all of you? All of you?
Yeah. So
Yes, Rajesh.
Rajesh, would it possible to quickly tell out the differences between these policies?
Yes, so we'll have a one session, so short one on the networking. I'll talk about it.
Okay.
Okay. Yeah. So guys, coming back to the proxy. So what proxy is doing? Okay. So usually in the fundamental session, I skip this discussion, but here let's understand that proxy is a component for the worker in the which worker you have you have in Kubernetes. So what is the work is been doing? So some of the basic fundamental work I showed you. And remember, the proxy means proxy. This image, you keep it in mind. Alice is one network, maybe node network. Bob is another network, which is a pod network. And you have to exchange the data between that. So pod is running on the pod network. That means pod is running and assigned with the networking address, which is of the pod network, which is a cluster network, you can say. Alice is on the node network. So between that, the data will be exchanged. How? Proxy. So here, what is a proxy? Characteristics of proxy. So the Kubernetes network proxy runs on each node. This reflects services as defined in the Kubernetes API on the each node. Can do simple TCP, UDP, SCTP stream forwarding. Can also do round robin TCP, UDP and SCTP forwarding. So both the way you can do that. This data exchange. Okay. So now this image is good. Look at this here. This is the image of kubeproxy. If you understand that at the high perspective, look at this here kubeproxy. And if you look at this kubeproxy, is doing what? So kubeproxy updating the IP tables. Okay, so saying that, hey, this pod I am giving this IP address, this pod I am giving this IP address. So what is happening the moment who instantiate a pod? Kubelet instantiate a pod, Docker fill the container inside that, and after that, that kubeproxy, what they do, they allocate the IP address to the each pod and update the IP tables. Look at this. So how this CIDR is decide the IP address range. So kubeproxy get the IP address range from the API server. Okay, and accordingly is doing that. So that is how that you get to know all this thing. Are you understanding, all of you?
So Rajesh, here the Kubernetes node is actually the worker node, right? What
Okay,
represented in that?
I'll tell you in this way. I didn't wanted to tell you now, but actually, here I've been teaching you kubeproxy is a one component in the worker node. Correct now? Correct now? But actually, kubeproxy in reality is a component for every node of the cluster. How? That I'll discuss little later. But for time being, understand that kubeproxy is a component which has to be run in each worker, okay, and each node basically, and which update the IP tables and allocate the IP address, sorry, pod IP address. So now, if you want to, if end user wants to access the pod, they don't need a kubeproxy for that. They will directly hit the IP tables through the IP address, IP tables, and IP address will tell where to transfer the traffic. Are you understanding? All of you? Okay. So now you see that all the internal communication, external communication. So now look at this. You talk to API server. API server store the data in etcd. Controller manager have multiple controller which monitoring each and everything and updating the API server. Scheduler also keep checking the API server for the work. If they got the work, assign the work. Scheduler assign the work to the through the API server to kubelet. Okay, so kubelet also keep checking the API server. Okay, and for the work, and kubeproxy also keep checking the API server for CIDR, IP address allocations, all this thing, and then based on that, kubeproxy assign the IP address to update the IP tables, and kubelet talk to the Docker for filling the containers and so on. So this is the complete communications between the different components of the clusters. Are you comfortable with this image? All of you? Hello?
So Rajesh, the IP tables that you show here, is it a Kubernetes software or is it a the
No, no, no.
OS software?
IP tables is the fundamental building blocks of any kernel for the networking solutions. It's a part of every host. It can be, it is a part of every physical server or virtual server. So it's
It's a
because
host
of
software.
IP.
It's a
Yeah,
host
it's a
software.
host. Huh. It's a table for IP for mapping the routing. It's the host software.
Yeah, I wanted to just clarify it. Yeah, thanks.
Yeah. Okay.
Rajesh,
So now, yeah.
yeah, so the pod will be created by the kubelet actually. The moment the pod created, the IP address has to be allocated. So that will be done by the kube proxy. So who will insert the kube proxy to allocate the IP for the particular node? So is that API server will insert the kube proxy to assign IP
Yeah,
address to the
so
particular?
what happened? Kubelet will instantiate a pod, fill the container, and then inform that API server. API server will have some jobs for kubeproxy to allocating the IP address for that particular pod ID, and update the IP tables accordingly.
Okay, API server will instruct the kube proxy to update, or a
Yes.
kube proxy
Yeah.
will ask to.
Everything, every communication, internal communication has to be passed through API server. Every external communication has to pass through API server, because if you do not pass through API server, then update to etcd will not happen, and you will not be knowing what pod, what IP, what pod, what status, what cluster status, and all stuff like that.
Okay, so I would like to understand the flow actually, whether the API server will insert the queue proxy to do some job, or the queue proxy on its own will ask the API server whether if I have any job to do. So how the flow?
See, I'll put it in this way.
Okay,
Think API server not as a one software. I repeat, it's not one software. API server is having collections of APIs for different work. So if you look at the arrow very carefully, Kubelet will ask a job from API server. An API server at certain endpoint, they will make it available all the job what Kubelet has to do. Okay, at certain endpoints, and Kubelet will pull that job and do the work and report back to API server saying that, hey, this is the request, I had it, and this is what response. And after that, it's all API work. Now API server, based on the some calculation, will make it some information available for kubeproxy also, saying that, hey, for this particular pod, I'm allocating this IP address, CIDR range, and all stuff like that, and please update to IP tables. Okay, so that means IP tables is updated with that IP address and pod ID and stuff like that. So when you hit to the network of the node, IP table will say, okay, let me redirect to this particular port, and this particular kubelet pod is nothing but application, right? So let me redirect to this particular port of that particular mind it here. One thing you have to understand: container is nothing but a process. I repeat, container is nothing but a process. Just forget about this Docker and Kubernetes. See, in the laptop, when you run Apache, it's a process, correct?
yeah,
And Apache get 80 port. So now you are running that Apache in the container and allocating some port. That's all. So there's a not much difference. So here what is happening? Kubernetes is creating pod. Now you will think, what is a pod? Pod is not something which is a physical entity. Container is a physical entity. Pod you cannot experience. Pod is just like a way to assign the group of containers. Make sense?
yeah.
That means group of process. Think in this way. Let's say I have a four process attached to one network. So if you really want to understand what is a container one and stuff like that, you can just go through some of my videos of Docker, and it will help you. I'll share with you later point of the time.
Okay, okay. Thanks,
So
Rajesh.
it's not like a virtual machine, it's like a process. Think is everything you think container as a process. The moment you understand the process, then what is a pod then? Multiple process. I am allocating one label. Pod is just labeling, nothing else. Is a way to label. For
Okay,
us, for us is a pod. For system, it's just a process. Container is a process. Getting my
okay.
points?
Yeah, got it. Got it.
Okay, so
Thanks.
coming back to this worker node. So yes, how do you configure a worker node? So you have to have a three software: install, kubelet, container engine, and kubeproxy, and so on. So now guys, this is the between the cluster to the communication. You can see the primarily arrow, which will understand. I have shown you already. So this is the one. Yes, so these are the three components which each worker will have: kubelet, kubeproxy, and a container runtime. So which we have discussed already. There are many other components also there, like a DNS for discovery, ingress for the application load balancing, and dashboard also. So we'll not discuss. So look at this. This is one of the image for the Kubernetes. Here dashboard, CLI, talk to API server, then these are the components. In the worker you have Docker, kubelet, kubeproxy, and they're managing pod 1, pod 2, pod 3. Pod you have multiple containers and so on. Okay, this is one more visualization. This is the one more visualizations where end user is also added. So developers means you as an ops engineer deploy some pod using this. All this you look at the arrow we discussed multiple times. And users when they want to access that pod, they will hit the networking of the worker node. Okay, so they will go through the kubeproxy and all this IP tables and stuff like that. This is a more elaborated image. I'll not consume too much of time. This you can refer it later also. Here, if you see etcd is also a three instance of it. HA. So this you can see that. This one more image from the load balancing side. So this will discuss again in service topics. So I'm ignoring it. Okay, so overall we have discussed master, we have discussed worker and their components, and then laptop you have a kubectl, and last component which is JSON. Last topic which is JSON. That means work if once the master is set up, worker is set up, and kubelet is also set up in your laptop. What work you have? Nothing else but writing a JSON. Then that means what you want. Okay, so that is a something which you have to do. Now before that let's understand JSON. So JSON or YAML, you can write a both. Okay. So what do you want? So that's called desire. How to declare in YAML, YAML JSON. Earlier we used to do in XML. I mean, not in Kubernetes. I'm saying these are the declarative language: XML, JSON, YAML. So nowadays we are using JSON and YAML, right? So what is your desire? What do you want from the Kubernetes? Kubernetes will give you. That's your desire. Declaring a declarative model language like YAML or JSON. So here you see manifest file YAML or JSON. What do you want? I want 3 pod of what? Nginx. API server, you got the 3 pod. How it worked? Now you know that. Now 3 worker, each one of these got the one pod. One node is not working. So what was the desire? 3. Actual 2. So controller manager will inform, hey, there is a 2. API server will check etcd. Desire was 3. Mismatch. Hey scheduler, please schedule one more pod. 3. Desire versus actual. Match. This is how it works. Are you able to understand the Kubernetes, how effectively it works? All of you? All of you? Hello?
Yeah, yes.
So guys, what do you want from Kubernetes? See, master is set up, worker is set up, workstation is set up. You would need to write a JSON. What you want in JSON, what you want in YAML, you need to declare what is your desire. So you want pod, controller, services, storage, not less. This is a little bit more. But by the way, we have a 72 resources, which I checked on Monday with the version 1.23. Remember, always it's keep increasing. Mind it. So that's you have to learn what you want. So first thing, let's say when you go to AWS, first thing what you do, you create a EC2 instance virtual machines, correct? So same way, when you go to the Kubernetes, you have to work with a pod. So the question is, what is a pod? So guys, very simple way. See, I don't know about the pod, but what I know based on the discussions, pod is been running in the worker node. In the worker node, you may have a multiple pod. In the each pod, you may have a container. In each pod, you may have a multiple container. Pod get IP address from the kubeproxy. That means if you want to access the pod, you can a container, then you have to access the pod IP address and then port number of container. Okay, this I know. Who instantiate a pod? Kubelet. Mind it here. I'm not saying creation, instantiation. There is a difference. Instantiation versus creation. You need to Google it and find out the difference. In the programming, this is a very important concept. So I'm always saying pod is being instantiated by kubelet, not created, because pod is not a physical entity. So it's like this. So that these are the information I know that for sure. But what is a pod? So guys, understanding this way, when you go to the VMware, what you do? You start the VM, create a VM and start the VM. When you go to the Docker, then what you do? Create a container, run the container. So guys, when you come to the Kubernetes, same way, you need to run pod. You need to run pod. So that means if you are in a Kubernetes, you need to run the pod. So VM contains what? VM contains operating system. Okay. Container contains what? Container contain the applications, root file system plus applications from the Docker image, VM from the VM image. Container do not have operating system, mind it. So pod contains what? Pod contains containers. Simple. So when the VM is running because of PID1. When container is running because of PID1. Pod is running because of all containers of pod is running. Simple. Are you able to get this? All of you, what is a pod? So pod is atomic unit of scheduling. Basically what happens, you can put it in a more simpler way. Pause is a way to group the containers and assign the resources. What resources? Network mount and any other namespace, kernel namespace resources. Are you understanding, all of you? Hello.
Yes.
Okay, so guys, pod contains containers. One pod may have a multiple containers. All the resources get allocated to the pod. So that means containers resources means network name resources, kernel resources, and all, which is get allocated to the pod. That means all container can access all the resources which got allocated to the pod. So when you have a two containers in a pod, we call it a tight coupling. When you have a one container in a pod, that's called loose coupling. Good one. So you should not deploy multiple similar container in the pod. That's the wrong practice. You should deploy, if you have a similar container, you should always deploy the different separate pod. Okay, so when you have a two containers in a pod, first container we call it a main container, second container we always call a sidecar container. Okay, so here main container and container share the all resources like kernel, network, namespace, amount, and everything which is allocated to the pod. Okay, pod can be scaled, so you can scale the pod. So when you have one pod ready, from there you can create another pod and it will become a pending. That means you can replicate basically pod replications, we call it. Okay, so you can replicate. So what is the state of the workflow of life cycle of the pod? So pod either will be in a pending stage when it's being created, then running, then succeeded and failed. You can't create a pod, you can't start the pod, you cannot stop the pod, mind it. Container you can create, start, stop, remove, all this thing you can do that. Pod you cannot do that. So pod is in pending. Why? Because container you see is not running, pod is running. Why? You see the container is running. Pod succeeded or failed. Why? Because the work of the container is completed in a failed way or success way. It's like this. So container is important for the pod. Okay, so when you have a two containers running in a pod and pod get IP address, so how can you access from outside? Simple, container port number and IP address of the pod. You can access from outside. If you have one container, super, you have a IP address anyways. So how this pod talk to each other, irrespective of the node. So they talk to each other on the node pod network, not a node network. So when you create a cluster, you have to create a networking. You have this. There's one pod network is being created, and the driver is like Calico, Canal, CM, VibNet. So many policy drivers are there. We call it policy. I call it driver because of my habit. Earlier, you used to call it driver only actually. Do you remember that when you install this operating system in in the laptop or desktop, you used to install the driver software, networking driver? Do you remember that? Anyone have done it?
Yeah,
Yeah.
used to
So
call
earlier
network driver.
network driver. Actually, nowadays name has changed and they call it policy. Simple. Driver is a software which you have to install it to work to connect the network. Simple. So nowadays we call it as policy. So many algorithms has come. Some of them are we'll use like a caliper we will use today. So yeah, they each pod they talk to each other on the pod network powered by multiple policies which I showed you before that also. Okay, so now if you have a two containers within a pod, they can talk to each other through the local host. But from outside, IP address of the pod and container port. Mind it. So what is a pod? So pod is nothing but has one or more containers. It can be your application, it can be your service. Now in Kubernetes, this is the most basic unit of work. That means work means container. And in Kubernetes, this is a unit of scheduling. Mind it, pods are inferior. That means no pods is ever redeployed. That means if you say Rajesh, I need the same pod, I cannot give you that ever in my lifetime. If it's gone, gone. Okay, I cannot get you the same thing. I cannot get you the same pod. I can get you the similar pod. Same versus similar. Please understand that. So pod are atomicity. Once it's gone, they will never, you will not get it. You have to get a similar one. They are there or not. Okay. So what is the job of the Kubernetes? Job of the Kubernetes is to running your pod. Remember, pending, running, succeeded and failed. So job of the Kubernetes is to running your pod. And when the pod is running, as long as containers are running. Remember. Also, Kubernetes also helps you to manage the to check the health of the pod. Also to check whether the applications are running or not. That's called liveness probe and all stuff like that. It can help you. Okay, so that is a pod. Okay, so this is the discussion which I wanted to make it. So what we have discussed so far, let me recall. First, we started with what is Kubernetes. Okay, that is the something which we discussed. Second thing we discussed, why do we have a Kubernetes? Why do we use a Kubernetes? Then third thing which we discuss, architecture of Kubernetes. Then we learn master node, worker node, and workstation. That means your laptop. Then we understand the component of master which is required to make the master master. Then we learn components of worker which is required to be set up to make the worker worker. And then we discuss about what you should write in a YAML or JSON. So the first component you will write is a pod, and then we discuss about the pod. Any questions, all of you? Any questions?